So in this example, we need to find out molar solubility of silver chloride, AgCl, in 1 liter of solution and 2.0 times 10 to minus 2 moles of HCl. Okay? So when you look at table, we find KSP for AgCl, which is at 25 degrees Celsius, we get 1.8 times 10 to minus 10. And we construct ice chart, okay? And when we construct ice chart, we have initial concentration of Cl minus 1 is 0.02 molar, because that's the mole of HCl it contains. Alright, so let's start with building ice chart. So AgCl solid and Ag plus aqueous, Cl minus 1 aqueous, and we have ice. We can have 0 Ag plus, but remember that solution contains HCl, so initial concentration is 0.02 molar, because it's in 1 liter, so 0.0 change is plus x, and then final is x, and this one is 0.02 plus x. Now we will write KSP. KSP is Ag plus and Cl minus 1. We can say x times 0.02 plus x, and then KSP is already been given, right? Now in this case, this change is very minute. So what we do? 0.02x equals, what's the KSP? 1.8 times 10 to negative 10. Okay? Now we'll solve for x. Now it's easy to solve for x. So let's go to next slide. We have x when we find 1.8 times 10 to negative 10 divided by 0.02. And we solve for x value, which is 9.0 times 10 to negative 9 molar. Now, you can see that's the molarity of KSP. And now let's check if it is KSP right or not. So KSP equals x squared. And we have 1.8 times 10 to negative 10 equals x squared, right? And then when we find x value, 1.3 times 10 to minus 5 molar. Now you can see solubility is reduced by a factor of about 1400 or so, right? Because this is the one we got, and this is the one we checked for understanding what we did. So it was reduced by 1400. This is really we got, and this one theoretically when we compare, it's what? Reduced by factor of 1400, right? So what we do? We can also use reaction quotient Q. And to determine whether precipitation will occur or not. precipitation will occur. So we will compare K value and Q value and we will try to find out whether the precipitation occurs or not. So now we are introducing Q, reaction quotient Q, and we will compare it.